Next is Boolean data type. So when we say Boolean data type, it means a type of variable similar to integer, long, and etc. But we use it for conditions. And if you remember conditions, when you say x greater than or equal to something, the answer is either true or false. What if you want to save this result? When we have numbers, we can save them into integer, long, and double. What if you want to save the result of a condition? So the definition for Boolean, the data type Boolean is a primitive, just like types integer, double, and char. It specifies only two values, true and false. So what values we can save inside Boolean data type is either true and false. Here are some examples of using Boolean variables. You can put constants inside them. So true is a constant. It's like when you say integer x equal to 3. So 3 is an integer. So in here, if you put Boolean, if you write Boolean found, so the name of the variable is found and the initial value is true. So store true or false to a Boolean variable. Another way is to save the result of a condition into this variable. So imagine you have a number, it is an integer, and its value inside is -5. And now when you test for number, is it greater than 0 or not? We know -5 is not greater than 0. So the result of this condition is false. Where it will be saved? It will be saved into a Boolean variable which is called is positive. So see the name of the variable, it looks like someone is asking a question. Is positive, that means maybe yes and maybe no. The third usage of inside if statement, and you know that for if statement, if we have a condition, the condition is either true or false. So here there is no need to check whether the variable is true or false. Just write the name of the variable Boolean, and if it is true, then the if statement will do the yes statement, and if it is false, it will do the false statement. So here, since number which is -5 is not greater than 0, so inside is positive will be false. When the if statement is evaluated, this is false, so it will go to else and execute this statement. If you want to read input and output, and this is very rare, it happens. Nobody reads the true and false data types. But if you want to read Boolean data types, then there is next Boolean. So the values true and false of the type bool can be read as input. So you can read the true and false, and we can also read true and false. Last thing in chapter number 3 is the switch statement. Now for Java, we have if, single if. We have if else, which is double selection. In addition to that, we have a switch. Now a switch is a special case of if else, if else, if else, if else, but we cannot use it for every problem. When we use a switch, you use a switch, focus with me, you use a switch if you are testing for one variable only. So if you have if else, and you are testing for two variables, then you cannot use a switch. So if you are testing one variable against many constants, so remember, one variable against many constants, and you are testing for equality, equals, then you can use a switch. So if you have a condition that has a greater than, less than, not equal, then you cannot use a switch. Single condition, so it is used to test equality of an expression against multiple constants. So you have one variable, you put that variable in here, so you say switch, and you put the variable, and this variable could be a single variable, could be an expression, and the answer coming out from a switch will be tested one by one in cases, case 1, case 2, and etc. The last one is called default, and default is like else, which is the last option available. Each constant tested and appended by colon. So one variable against many constant, if this variable equal to this constant, this statement will be executed, and there is a break in each case. So we call each part here, we call it a case, حالة. So if you don't put a break, then when the computer comes to this case, it will immediately go to the next case, like if there is no wall between them. So when you put a break, it looks like you are putting walls between cases. And if you don't put a break, then you are having more than one case without breaks. The controlling expression, which is this one, must be of an integer type, short, or byte, or string, or char. So here you cannot use double inside here. You cannot use Boolean, okay, because it says integer, short, byte, and char, and you cannot use long also. So this may be a multiple choice question. So inside the switch, these are the data types available. Each constant is a constant of the same data type. So if you put here integer, you should not put the constant strings because you are testing for constants of that variable. A break may be omitted. Omitted means skipped. You cannot write it. But without a break, execution just continues to the next case. So if you don't have a break, this is like a wall between these two cases. If you remove this break, then you are removing the wall. And when the computer comes to this case, it will immediately go to the next case. Any number of cases is allowed. And then a default case, which is the last one, is optional. This is like last else we have in multi-branch if else statement. Without one, no action occurs in the event of a mismatch. We will go for an example here, and we will take some cases for the value of watts. See, this is the single variable watts. And before I proceed, maybe I should talk about the syntax. You write a switch between round brackets, you put the variable. You have open curly brace and you have a close curly brace. And inside, in multiple lines, you write case, you put the constant colon. You write case, you put constant colon, and then inside each case, you put statements with a break. Statements with a break. Here, what we are testing a variable called watts for the wattage of bulbs. Bulbs is like a lamp, okay? Depends on the wattage, how many hours this lamp can last. So it's like an age of a lamp. Now, if the wattage is 25, then the life for this bulb is 2,500 hours. If it is 40, if it is 60, then 1,000 hours. 7,500, it will be 750. Otherwise, it will be 0 because we don't have lamps, bulbs other than these wattages. Now let's take some scenarios. Suppose wattage is equal to 60. Now what happens? The computer will check. It is 25 is not 60. It will go to the next one. It is not 60. Once it finds 60, it will go inside and will save 100 or it will save 1,000 into life. And since there is a break it means go out. So it will go outside the switch and continue the program. What if wattage is 70? Now it will check for the first case, it is not 70. Next case, not 70, not 70, not 70, not 70, so it will go to default. So in default, it will put 0 into life. Now again, if you remember for a break, we say that a break is like, a wall. When it comes to break, it will take you outside. But what if you don't have a break? See for case 40, there is nothing in here. And also see for case 75, there is nothing. So what happens if wattage is equal to 40? First, the computer will check at 25. It is not 40. Now, when it sees 40, it will go inside. But inside, there is nothing. And there is no break. So there is no wall. Immediately, we'll go to the next one. And what is in the next one? Without testing. And the next one, it will put 1,000 into life. Now, imagine, now this break does not exist. So if the wattage is 40, what will happen? The computer will check for 25. It is not equal to 40. There is a break. Okay, sorry, we are not entering, sorry. We will check for 40, it is not 40. Now we will check for next one, it is 40, so it will go inside. But inside there is nothing. It will go to the next one, so it will put 1,000 into life. And again, there is no break, it will go to the next place, and there is nothing. And it will go to the next, it will put 750 into life, and now there is a break, it will go outside. So what is the last value of life? It is 1,750.